A lot of internal work that is done at the media level. For example, when you have a conference, you have many streams that are incoming into one FreeSWITCH box, and then they are converted to a common format that is a raw format, a signal linear internally, and they are all mixed, then retranslated into the various client format and broadcasted to them. Another important function is Spark and Spark calls is managing both queues and automatic code distributions. I mean, all those things that involves media handling and statefulness. So, for example, in a queue, a call is incoming, and you take care that the caller hears some music on hold, some announcements, and after a while you tell them to at which position he is in the queue, and hopefully in how many minutes he will be served. And then you follow the progress into this queue, and at the end you connect it to an operator. And those are part of what is done inside one FreeSWITCH box. That and from 1,000 miles point of view, one single FreeSWITCH is handling both media signaling and does all its own state. And what is the first step to achieve high availability? The normal first step that you go toward is just let's duplicate the machine and have some way to switch from one machine to another machine if the first machine goes down. It's important anytime you implement high availability to double it all, because it's not only the machine, your server that can fail, but it's your switch, it's the cabling, is all the things that are around your machine, and possibly is also your carrier, your ITSP. So it's better to have at least two carriers, or stay in a data center that has two independent feeds and two independent network where you can be failover in case of some accident. How you do that? You do with the our standard network elements that we all know, and you move the virtual IP address. You have two FreeSWITCH machines that are completely the same. One will be the one that is used by clients, and the other one will be just a standby there. And what is your mission is to keep those two machines completely in sync for what is their state, for what is their configuration, and to be ready to be switched over from one to the other. And for this, you will be using DRBD or rsync or GlusterFS or NFS to keep the file system synchronized. And you will do the same for the standard database that is kept on file system. You will move then the IP address from one machine to the other using the standard systems of high availability, that is Heartbeat or Keep Alive or Core Sync or Pacemaker, those things. In this first configuration, you will have those two machines in an active-passive way. So this is our first configuration. We have two machines, actually, one FreeSWITCH and the other FreeSWITCH. And Keep Alive will move the virtual IP address from one to the other. So one machine is constantly idle, and one FreeSWITCH machine will be, a complete machine with a lot of power, and it will cost a lot of money to have it just standing there idle, doing nothing. And we know what it happens when you have some big resource that is standing idle. There will be some creep, and you will begin to have that little things that is running on the idle machine, and then another one, and also you will never exercise actually if it will work, and after a couple of months you will never be sure that that machine will work and that you actually have a spare standby ready to take over. So actually you have one entire machine that is completely idle, and that's a big something that you don't want to edit. And the problem is that this kind of setup can only scale vertically. So if, let's say, you pass from 100 concurrent calls to 300 concurrent calls, your only option in this setup is to completely substitute those two FreeSWITCH machines. I mean, hardware. You change the hardware, and you buy a bigger server. I mean, with more sockets, with more CPU, whatever. But you must change your hardware. And as you know, the most powerful the hardware is, the most it costs, not in a linear way. I mean, if you have to double the power of your server, it will not cost the double of one of the original server. It will cost much more. Horizontal scalability is what you achieve when you augment the capability of a system just adding standard machines. So you reach the boundary of your system with two machines. Okay, you just add another machine, another unity of power, and it scales linearly as cost and as operation. So you just keep adding machine, and at least in theory, you can scale indefinitely to millions, of course. And you just distribute requests on resources. Yeah, here we are arriving at our real aim. So creating many FreeSWITCH boxes that act exactly like one only box. And we see that previous slide of what a single FreeSWITCH do, has its own configuration, keep its own states, etc., etc. And we see how we can do that with a farm of FreeSWITCHes. We use a database to keep the state. We use a distributed file system for configuration, voicemails, and those things. We use redundant and high available balancer and proxy to distribute signaling and to handle not related both media and signaling. And you do partition with failover to manage specific tasks that cannot be managed between different machines. Obviously, you cannot mix streams that are incoming into two different machines. You must have those streams incoming on the same machine. You achieve that with partitioning, and we will see that later. Wow. That becomes a little bit complex, and I really, really envy Lorenzo that talked before me, because they have always those so nice slides, and I'm completely unable to recognize the slides. But I hope that at least you can get the knack from this one. Okay. Here we see that we have something that is complex. Why that? Because we have fundamentally exploded one FreeSWITCH with the aim to replicate its functionalities, but without having limits. This kind of setup can scale indefinitely. And fundamentally, we have, let's start from the left. We have our clients, our callers, and they send their signaling to our redundant proxies. Here is OpenSIPS. And OpenSIPS then answer to them, managing the NAT, and so giving to the clients the address of our proxy media relay for sending the media, and from that media relay, the media will go to the to one FreeSWITCH server on the backend. Same thing with the signaling. Signaling will be distributed on the backend. Each of the FreeSWITCH server in the backend are accessing their own state and their own configuration from a distributed file system, that's GlusterFS, and from a remote database that is maintained in high availability by clustering, that is PostgreSQL with BDR, bidirectional replication. This is, let's say, 1,000 miles look into the platform, and we now will pass through the different components of the platform. Is this all clear until now, or if we need, if someone want to ask something right now, please raise your hand. If not, I will continue. Okay. In this setup, we also have one machine, one function that is constantly idle. That's because we need to publish one only access point for client to call in. So we will have also in this case, like in the case that we have the two FreeSWITCH machines, one active, one passive, one that is actually doing things, and the other that is just a passive standby. We also have the two entry point where the virtual IP address is moved by keep alive. But in this case, this is not so big a problem because it's not at all a big machine. I mean, OpenSIPS proxy, C proxies are so optimized, so powerful, and they only deal with signaling, so actually they need very low resources, very little machine to run on, and they can manage thousands and thousands and thousands of calls. So it's not a problem to have one standby, and you need it because you have to do the failover when you need it. The other advantages of this platform, of this setup, is that all of it is constantly exercised. All of it is working. You are using all of your hardware at full, and you just scale adding machines. So it scales horizontally and in a linear way. So the more business you have, the more money you throw at it, but not in a not in how do you say?
Exponential.
Okay, not in an exponential way, but in a linear way. And this also you see that only this little one will be idle, and I mean it's an idle machine that you will probably exercise often when you want to to do some maintenance. Why we need all these complexities? Mostly because please.
I had a question. Can you flip back to the other slide? There you go. So even in this case, another approach could also be that you're splitting your again, like you said before, partitioning your traffic between customers. So instead of having an idle box, you could have two smaller boxes splitting your traffic using DNS to shard your customers, right? Partition your customers. With 1,000 customers on box 1, and box 2 could easily cover 3,000 customers. But why not put 1,500 on each? And if one goes down, you're only affecting half your customers. So we've seen that. I mean, I've seen that approach, and we use that approach quite often. It's not a scenario where, okay, OpenSIPS is amazingly powerful. You could put tens of thousands of calls on it. But at the same time, why would you want to risk that many customers all in one, basket when you could easily shard them and use DNS to fail over, to vice versa boxes?
I completely agree with that. And when you have, let's say, a carrier or a very big installation, that's definitely the way to go. I mean, partitioning, redirecting, load balancing, the balancer, etc., etc., etc. But this, and you will see also on the registrar in a while, is to teach how to pass from the concept of one only machine to the concept of a farm of machines that works exactly the same way. I mean, you don't take to change your configuration or your things. It is not what I will run a carrier or a telecom onto. I would definitely use that way, but at that step, you really change your approach and your mind. At that point, you use mainly proxies, and then you have some media servers that do things. That's not this case. In this case, we are scaling, let's say, exploding one FreeSWITCH and make a big one.
Gotcha.
But definitely that's the way. So we have that complexity mainly because we have to deal with NAT. In IPv4, and it's here to stay, probably forever. We will need to deal with network address translation, and so we will have clients that can't talk each other, and also we will not expose into the public internet or the same network our internal server farm. So in any case, we need a media relay that will carry the media from outside to inside. And one big mission or function in this case is to keep a pinhole that is constantly open in the house of our caller. Our caller is probably calling through some IDSL or something like that, and is behind a NAT. He has his own private addressing that is not routable on the internet. So problem is that the device that allows our caller to talk to us, to call us, it will not allow us to call him back if not we are using exactly the same port and the same port and IP address that he used to call us. So that's open a pinhole, and we need to continue to use that pinhole and to keep it open. Normally it stay open just 30 seconds, and we need to continue to have it open, so we send some ping to our caller, to our clients, and he answers. In this way we keep the pinhole open. I will try to go fast now because they told me that time is running. And that's the other big difference that I was anticipating. In a carrier setup, in a big setup, I will definitely put a registrar and all this function of option, notifies, presence, all those things I will put on the proxy and outside FreeSWITCH. Why that? Because those are high frequencies and operation that you don't need at all a software with media capabilities to handle that. When you want to just have one big FreeSWITCH and don't change at all your configuration from one machine to 50 machines, you keep it all into the machine, FreeSWITCH machine. Let's say the part that is more related with OpenSIPS and media relay, so maybe the part that you are more familiar with, and OpenSIPS can use for doing the code distribution both module of dispatcher or load balancer. A load balancer has the capability to understand how much one box is actually loaded, so it can optimize the distribution. And Keep Alive is used to move the virtual IP between two load balancers. That is made because Keep Alive has the ability to interrogate the machines, and we will use SIPSAC for that, just to understand if OpenSIPS is working correctly. To do NAT traversing and media relaying, we need to use an external entity because C proxies do not deal with media, with RTP, and but OpenSIPS has ability to command and to control one or more or a farm of external entities that do the actual media relaying. And in this platform we implemented with the most known of them all, the father of them all, that is RTP Proxy, actually named. And but there are many advanced ones that can be used. This is probably the minimum OpenSIPS script that you can use as load balancer and to control media relaying. We see that we select a destination, one of our backend FreeSWITCH server, here, this is using the dispatcher module, that is the easier one. Then, if we see that we have not into the user agent, we fix it, and then if it was an invite, we engage RTP proxy. With this function that is aided by the dialog module, the arming, disarming, and the shutdown of RTP proxy is automatically managed by this only function. So you actually don't need to worry about offer, answer, and all those RTP proxy subtleties. FreeSWITCH farm. FreeSWITCH standard keep its state into an internal database. That's the basic level is a SQLite file on file system. And but you can set FreeSWITCH to use a remote Postgres both for SIP related and for its internal state. And just with those two settings, we move. On each FreeSWITCH machine, we put an HA proxy that will automatically load balance SQL requests between PostgreSQL servers and fail over. I mean, if it knows that one SQL is down, it will only use the other one. Same thing for what it happens on the file system. And we'll see better here. Server will export bricks, clients will mount bricks, all is kept in sync in real time, and if one server is down, writes and read are automatically and transparently routed to another server that then is synced back when he's brought back. Postgres bidirectional replication. This is a new technique that will be part of one of the next PostgreSQL release that is able to do a real-time clustering of Postgres. And you have to create primary keys that are unique and not colliding, and each table needs to have a primary key. You cannot have a table without a primary key if you use BDR. And so there is a way to do that. It can be or modifying FreeSWITCH or making a default unique ID primary keys on Postgres. And I will send a patch upstream for FreeSWITCH so it will automatically do that. Special cases, when you have conferences, call queues, call centers, you cannot do audio mixing between two different machines. You have to have the actual audio stream on the same machine for you to mix it. I mean, it's a physical thing. And how you do that? You do by partitioning. You For example, this is a very easy case where you first check if caller is trying to reach a number, an extension that is one of the conferences extension. That's mimicking the standard FreeSWITCH dial plan where 3,000 etc. number are for conferences. If it is, you select a destination from the dispatcher set number 2. The dispatcher set number 2 is made in a way that is composed by one active machine, and in the case you will go to another machine. The other one is the standard dispatcher machine sets that is around robin. It will take some more explanation, but that way we can scale very well, because from one side we have a set of round-robin machines for, let's say, normal things, and we can use some of them as a special machine to do the mixing in special cases like conferences or ACD or code queues. I hope this is a book that is out right now. This will be out, hopefully, I'm trying to do my best, for August, and we will begin to distribute our ClueCon, and that's it. Okay. Thank you. There is time for some question? No.
There is not.
Okay.
I apologize, but if anyone's got questions, they can catch them outside here as we're leaving for lunch. We've got 1 hour. The room's going to be locked, so everybody can go ahead and leave their equipment in here, but we're going to ask everybody to leave the room in order to lock it. Back at 1:30, everyone.